Hi friends, welcome back on our YouTube channel. This is the next lecture of optics in which today we will discuss about formation of image and Newton's formula. So in the current lecture we will discuss about formation of image by cardinal points and the Newton's formula. Now, what is cardinal points? This whole thing we have discussed in our previous lecture. In this lecture, we will discuss about formation of image by cardinal points. So, formation of image by cardinal points. Now, this is our principal axis. These are two principal points. F1 and F2 are first and second focal points, and H1 and H2 are first and second principal points respectively. N1 and N2 are nodal points. AB is our object, and let the size of object is Y1. Now, a ray parallel to principal axis after refraction from the lens system passes through the focus F2. Now, this is our ray which is parallel to principal axis, and after refraction from the lens system it will pass through the focus F2 according to this rule. So, this ray passes through the focal point F2 after refraction from the lens system. Now, second rule is a ray passing through F1 become parallel to the principal axis after emerging from optical system or from lens system. So here we have a ray which is passing through the focal point F1, and according to this rule, this ray become parallel to principal axis after refraction from this lens system. So this will be the direction of ray when it refracted from the lens system. M1 and M2 are 2 points. Now, third rule, a ray meeting first principal plane at any height emerges through the second principal plane from the same height and on the same side of the optical system. So, M1H1 and M2H2 are our principal plane. This is our first principal plane and this is second principal plane. So, array AM1 incident on point M1 on the first principal plane, and after refraction from this lens system or this optical system, it emerges from the same height from the second principal plane. So H1M1 is equal to H2M2, and it also passes through the same side of the optical system. So it passes from M to F2. It means in between these two principal planes, the ray become parallel to principal axis. A ray directed towards a nodal point N1 emerges through the other nodal point N2 parallel to the previous ray. So this is a ray which incident towards first nodal point N1. So after refraction from the lens system, it will pass through the nodal point N2, and this ray will be parallel to this one. So it passes through the second nodal point N2, and also AN1 is parallel to T2 N2, and in between these two principal planes it will be parallel to principal axis. So M1 M2 is parallel to T1 T2 is parallel to H1 H2. Now, where all the three rays or any two rays meet together, there we get the image of our object. It means the image of object AB will be A1 B1, and let the size of image is Y2. Now Newton's formula. This was our diagram. Let these 2 points are K1 and K2. Distance of object from first focal point, that is BF1 equal to x1, and the distance of image from second focal point, that is F2 B1 is our x2. Let the distance of first focal point from first principal plane, that is H1 F1 equal to F1, and let the distance of second focal point from the second principal point is F2, that is H2 F2 equal to small f2. Now from triangle ABF1 and triangle F1 K1 H1, so ABF1 and F1 K1 H1, K1 H1 upon AB, K1 H1 upon AB is equal to H1 F1 upon BF1, H1 F1 upon BF1. So K1 H1 upon AB equal to K1 H1 upon AB equal to H1 F1 upon BF1, and K1 H1 equal to A1 B1. So A1 B1 upon AB is equal to H1 F1 upon BF1. Since A1 B1 equal to minus F2, this is by using sign convention, and AB equal to Y1, because every distance which we measured below the principal axis are negative and above the principal axis are positive. So AB equal to Y1, whereas A1 B1 equal to minus Y2. Also H1 F1 equal to minus F1. So H1 F1 equal to minus F1, because this distance is measured in the opposite direction of incident ray. So this will be negative. So H1 F1 equal to minus F1, and BF1 is equal to minus X1, because this is also measured in the opposite direction of incident ray. So BF1 or F1 be equal to minus X1. So by substituting these values in this equation, we get minus Y2 upon Y1 equal to minus F1 upon X1, or minus Y2 upon Y1 equal to F1 upon X1, because this negative sign and this negative sign will be cancelled out. So minus Y2 upon Y1 equal to F1 upon X1. Now this was our diagram. From triangle A1 B1 F2 and triangle M2 H2 F2. So from triangle A1 B1 F2 and triangle M2 H2 F2. So A1 B1 F2 and M2 H2 F2, A1 B1 upon M2 H2 is equal to B1 F2 upon H2 F2, or A1 B1 upon AB, because M2 H2 equal to AB. So A1 B1 upon AB equal to B1 F2 upon H2 F2, and A1 B1 equal to minus Y2, whereas AB equal to Y1. Also H2 F2 equal to F2, H2 F2 equal to F2, because this ray is measured in the direction of ray, so H2 F2 equal to positive F2 and B1 F2. So B1 F2 is equal to X2, because this is also measured in the direction of incident ray. So B1 F2 or F2 B1 equal to X2. Now on substituting these values in this equation, we get minus Y2 upon Y1 is equal to X2 upon F2, or minus Y2 upon Y1 is equal to X2 upon F2. Now minus Y2 upon Y1 is equal to X2 upon F2, and minus Y2 upon Y1 is equal to F1 upon X1. So by comparing these two equations, we get X2 upon F2 is equal to F1 upon X1, or X1 X2 is equal to F1 F2. And this formula is known as Newton's formula if same medium is available on either side of length system. So on the left side of length system and on the right side of length system, mediums are same, then the focal lengths will be equal. So F1 equal to minus F2 equal to F, and hence the Newton's formula in this case will be X1 X2 equal to minus F square, because by substituting F1 equal to F and F2 equal to minus F, we get X1 X2 equal to minus F square. So this is the Newton's formula when the same medium is available on either side of length system. Now here we end our session. In the current session, we have discussed about image formation by cardinal points and Newton's formula. So goodbye.